Hello everybody, and welcome back to the channel. This is Michael, KE4EST, and we are back here with this Heathkit IT-11 capacitor checker. Well, it'll do resistance and inductance and things like that, work out turns ratios on transformers, but we're going to mainly worry about, the capacitance part of it. We'll start with the front here. Everything's back together, and zoom in a little bit here on some of this. You can see, some of these things are still, it's just the gray. Some of this is the metal, and some of this is the gray, the light gray, as you can see here, because you can feel that a little bit, just barely feel that around the edges where they've sprayed on a coat of gray paint, light gray paint, and then put the dark gray, with the other stuff. And then you can see, like up here, get it up where you can see that. Around in here. I don't want to focus that far, does it? There we go. Some kind of overspray. I got as much as I could, but I didn't want to get too aggressive and start taking more of this paint off. Because as I've said in other videos, you can get too aggressive and you start pulling all this off, and then it really be a mess. It may look bad, but you start pulling your scales off, and it's really about useless. And you can still see right there, see that where it must have set like this right here for a long time, because you can pull that down and see where it was setting. More like moisture or something's got behind that. And you can see this has got a yellowish tint to it. And I cleaned on that until I started to almost take off. You can kind of see some of this black back there was actually on there that I took off a little bit accidentally. See that? So I'll quit on that. But I got looking at some other pictures and images online where people's had pictures of these, and from what I can tell, there's a lot of them that was yellow like that. So I don't know if that's the original color, or the plastic just, a lot of plastics will do that, and everybody else was afraid to take it off, the Mark II, so they just cleaned it and left it like that. I don't know. And then down here, ain't my favorite way to go about this, but I've got these here, just wouldn't, the original ones over here just would not, they was just way far gone, corroded. There was more damage inside than I thought they were. One of them couldn't even get to come loose. Soaked it in vinegar and everything. So I went with these, and every one of these, I have 3 or 4 different kinds of these banana jacks. And every one of them, they'll just go right through the original hole that's in there. So I put these washers behind it. For now, maybe down the road I'll come across another one of these that somebody don't want $1 million for it. And I'll just use it, as if it's in better shape, I'll restore it and use this as a parts unit, or vice versa, or whatever. At least, get more of the original ones. But it ain't gonna, this restore wouldn't restore that I knew was gonna be just a perfect mint restore, because of the issues here. So it'll work for now. And these jacks here I probably won't even hardly ever use. If you got an external standard you can feed in here, an external generator, I won't use any of that. But anyway, so that's what I done there. Let me see. Start on this side here. Some of this I know I already showed you. Of course, these electrolytics got replaced. I went through, and as I had stuff, unsoldered here, I checked a lot of the resistors, and all of them was real close to the spec. Which kind of amazed me. I knew it wasn't really amazing, because these here, you know, these Allen Bradley style, they usually do pretty good and hold their value over the years. But with this one being in such bad shape and stuff it went through, I don't know, but you know, they all hold pretty good. I found one on the back side that I changed out. Now, I didn't check every single one of these, unsoldered every single one of them, but I checked, you know, the ones I had loose, that I had to take loose for whatever reason, and they checked out good, so I just went with it. And this here, I meant to straighten that up. I don't know why somebody did that, but I ended up just soldering it back in there, you know, just going with it and putting it back. And after I got done, I was like, oh, wait a minute. Got this crooked looking thing here, but it'll be alright. Of course, I cleaned all the contacts here, cleaned the pots out here, sprayed them out really good and cleaned those. Now you can see on this side here, cleaned that switch there. And you can see the capacitor I was talking about in the other video, how it comes around, goes here to this potentiometer. There's that one. Everything's been cleaned up. This tube's been replaced. I also replaced the eye tube. I did an initial fire up of this thing once I got everything in. And a lot of times I'll do that. After I get the electrolytics replaced, I'll put them on a variac, bring them up and see what's going on, especially with one like this. That way I can kind of start seeing early signs of problems as I'm going to, you know, while I'm in there repairing it or restoring it or whatever. And it was just really, really weak. So, you know, even turned the lights off and it was just like, man, I can't really see that. So I went in and checked all the connections here. They were fine. I checked the resistor here, checked the voltages. The voltages were fine. All that looked good. So I was like, okay. You know, if this thing sits and somebody leaves it on a workbench all day long, sometimes people just leave these things on, you know, days at a time, especially if it's a repair, you know, shop or something. So I was like, okay. And I thought I had one, I didn't. So that's one thing, took a little bit more time to get back to this. And with this crazy times we're living in right now, trying to get stuff in, but I looked around, found a couple and ordered a couple and replaced that. So I think everything's been, the only thing I didn't do, and I'll show you, and I always do, but with everything going on, trying to, you know, really go through this thing, so much cleaning I had to do, I failed to go ahead and replace these safety caps here. Or, well, these are just regular capacitors here across the line. And if one of these was to fail, they usually fail shorted, and it'll take the line to the chassis. If it don't blow a fuse, they'll, you know, go and have a hot chassis. Depends on which side fails, which way you got it plugged in the wall. It's a two-prong plug. So I've got to go in and replace those with safety caps, some XY caps. That's the only thing I didn't do, and I realized that before I started shooting this. I was looking through everything. I was like, oh, thought I was ready for this, but with my time and whatever I got to do to get this done, so because this is shot in several different scenes, so anyway, so that's everything I've done. The line cord's good enough to leave it. So now we're going to go through and let me still got it hooked over here. This one, there'll be no reason just to bring up slowly, since I've already done that off camera. But I'm going to go ahead and go ahead and turn it on here. Now remember, when you're doing especially one of these here, keep this voltage down to 3 volts. But even if it down 3 volts, there's 600 plus volts in here. So be very, very careful and pay attention. If you ain't comfortable, don't do it, because this can really zap you here. This has got a lot, of course all the tube equipment does, but this has got a lot of voltage in it. So make for a very, very bad day. So, and I've got, the cover off here. Alright, let me turn this light off here. And let's see. Turn it on. Okay, tubes are lighting up good back there. The eye tube always takes a little bit longer, especially 6E5s. It should start coming in here in a minute. And there she goes. And you can see it. I put that down, you can see it kind of dim just a hair. Even though I'm 3 volts because it's changing the circuitry. It's not throwing a lot of voltage on anything, but it's changing the circuitry. And I've got the schematic here. The way it is, I've got it on 2 pages. But I don't see a whole lot of reason really going over the schematic a whole lot on this one. You can go online and get this real easy. This schematic for this. And it's pretty straightforward, simple schematic. If you happen to order one overseas or whatever, you want to check it, here in the States or in North America, you might want to change your transformer winding, wiring on it. But you probably can't see that really good. I don't have the light on. Let me turn the light back on here. Alright. I think I've got everything set back up. I had to cut that. That's what happens with a lot of these videos. Sometimes they're shot over a couple of days and a couple of different days and a lot of different takes. Sometimes I'll shoot a 10-minute, just rattle on about something and go over and talk about it, and then I'll go, oh, that ain't gonna work. Or I'll shoot it, take a break, think about it's run through my head, what I just did, and I'm like, I don't even like that. I don't even watch, didn't even watch the video. Just say I don't even like it, and it's gonna get changed. All right, so what we're gonna do is go through this here, and let's see, bridge cal. We're gonna go through and do the leakage calibration. Now, the bridge calibration I've already done off camera. Here, I want you to put a 200 ohm precision resistor across here. I think I used, you could actually use, a different one. I think you can see what it wants you to do is try to get it right here, because 200 ohms. You see there, but it's got a glare. 200 ohms here, so you can put that right there. So you can start off there. You might get a little off on the ends, because this is it as far as this scale goes. That's how you calibrate it. You throw a 200 ohm resistor across there and set it up. I used a 1K and a 500. That's what I had. That was precision. Okay, you got to back the set screw off and try to overcompensate, because when you tighten it up, it's going to move just a little bit till you get that where it lines up right. That's how you would do that. Put the 200 ohm resistor across it with this over in the resistance times 1 range, and the bridge leakage thing would be in the bridge, flipped up to the bridge, and I don't think it really matters about these, and these be set on internal and all that. Alright, for leakage calibration, there's 2 calibration procedures which can be used. The first without, and the second with a milliamp meter. The first is quite satisfactory. However, the second procedure will provide greater accuracy. So what we're going to do is just do the first procedure without don't use a milliamp meter in line. A current meter. So turn on the instrument, allow it to warm up and all that stuff, and then it says put a 100K resistor across the test terminals. Okay, so we're going to do that, and I've got, here's what I'm going to use for that. Let me move Yeah, I guess that's alright right there. So I'm going to adjust that top one I showed you, okay? Alright, so let's go in. Let's go in. I've got this on 300 volts, set on C1, electrolytic, and all this is just always stays on the internal there. Across the terminals, I've got a 100K resistor. We're going to go to leakage, and watch that I. What you want to do is go to the top potentiometer in there, adjust it to it just closes. There we go. Right there. Just closed. It's not, it'll close. You can overlap, but you don't want to overlap. You want just closed. Okay? Just make sure you put that in the discharge and bring this voltage down 3 volts before you touch anything. Just get in the habit of that if you're going to use one of these. You can quickly come across and zap yourself. It'll be a bad, bad day. Okay. Now, it says move the bridge leakage switch to the discharge and remove the 100K resistor. We did that. Connect a 1.5 mega ohm resistor across the test terminals. Okay, let me do that. Okay, done that. I set the voltage as follows: 25 volts. 25 volts. The type, set it to Minlick. Okay. And leakage. Okay. And then it says just the I tube to the just closed position with the bottom calibrate control. Okay. So I'm going to come down to the bottom control. You can see, I need to zoom in a little more here. I want to adjust that just closed. And you can see how it kind of starts to slowly, so you overlap. It's okay if it hits a little bit. About right there. Okay. And then set the controls as follows. Get this where you can see it. Where are you at here? I got it zoomed in. Oh, I got my monitor backwards. Set the monitor is mirrored. It is flipped and I hit the wrong button on it and I don't want to reach over and mess with it. Adjust the I tube. No, you can't see. Here we go. So it looks backwards to me in the thing, but you'll see it just fine. Adjust the I tube to the just closed. Oh, we did that. Set the controls as follows: 3 volts, paper, and then go to leakage. And that's with it still hooked to a 1.5 meg resistor. So leave it at 3 volts. I'm going to bring the type switch down to paper, mica, etc. Then go to leakage. And adjust the AC control. It don't say here, but I guess, oh, it does say the center one. So I guess you just have to, you should know it by now. There's one left. So we'll adjust that to the just closed. Right. What I like to do too is get it on there. Come on. Cause I'm like right now that's open. Yeah, I'm turning, open, close. See how it done that? turning, even though nothing's happening. I'm barely moving that a little bit. I'm adjusting that control up, down, up, down. Where to stay. I'm not got my hands out of it. Okay, so that's it. Discharge on 3 volts. Okay, then it goes into adjusting the eye to very, very carefully reach in, and if this is over here, you want it to look like this. You know, adjust it. You know, in the clip that's holding it, you want to move it around. Alright, let me reposition the camera a little bit here. Alright, let's do some testing now. Okay, so we're going to test this out. Right now I've got this one of these Illinois capacitors hooked up. It's a paper. It's one of those really good ones. This is a new one. So we're going to test it out. I've got it set for paper. We're on capacitor. Alright, so I'm going to start with 3 volts. 6 volts, 10, 15, 25, 50, 100. We're just going up. I'll wait at 600 because this is rated for 630. You don't want to go over what it's rated. You'll have something pop in your face. Maybe. I mean, this is current limited, but still it could explode the capacitor. Let's discharge it. And be careful doing this too. Don't go down and hit the 600 volts. So that's what they're supposed to look like. That's what it's supposed to do. Okay. So it's discharged, so we can take it off. Now this here is one of the electrolytics that came out of this unit. So I'm going to put the negative there, the positive. Make sure you get the polarity right. Okay, and I'm just using this alligator, you know, test lead. You can get proper leads or whatever if you want to use, or some people use really little short ones. I have little short leads coming out the front of it here. That way it's not dangling, wires going everywhere, or something possibly to jerk, grab a wire and knock it and shock yourself while it's testing. So you know, just be real careful doing this. We don't want 600 volts going through you. Okay, so this one's electrolytic, so we're going to bring it up to here. And go. Now that's 3 volts. 6, 10, 15, 25, 50, 100, 150, 200, 250, 300, 350. It's not bad. Now I will tell you, this one I have been playing with off camera in between takes, making sure everything's working right, and it's almost got itself reformed. When I first hooked it up, it wasn't going that fast. But okay, now be mindful, everything's still live. 350 volts is on this. This is on. I wanted to show you something. Look at this eye tube here. When I go to discharge, what'll happen is it'll close and then open, and once it opens, then it's discharged. Now something like these little caps here, you know, whatever, they're going to go discharge pretty fast, but the bigger electrolytics is going to take a little longer. Okay, so if I go discharge, there, it's discharged. Okay, while it's hooked up, let's see, bring the light back a little bit. I know it's going to make it harder to see that eye for you. 40 microfarads capacitance. It's way up here. So let's see. Let's go to bridge and see how close it is. Gotta get the maximum opening. Well, it looks like it's on 50. Which is normal as these age. The capacitance will start to go up as more resistance comes in. So, or the capacitance will show more. It may be the same capacitance or pretty close, but since there's that parallel resistance in there, you're going to start to, capacitor checkers is going to start reading a higher capacitance. And we're on the edge of our scale here for this old analog, you know, setup. It's not super accurate, so it's going to be off a little bit too. Power factor. You see, let me just get rid of this light. And get you back on that eye tube a little bit better here. You see, when I adjust the power factor, see that move? I know it's hard to see in the camera. Barely see it moving. But you want to adjust your power factor for the maximum opening, which is not all the way down, so we're about 5%. That'll tell you what, you know, so you can go from that, and if it's way up here, definitely bad. It'd be like, what you'd like to see is you try to move this up and it just gets narrower. Down at 0 is good, and that's really only going to, you know, apply electrolytics and stuff. Okay, or discharge and all that. Let's go to this other one. This is the other one that came out of here. And make sure you hook the polarity up properly, since this is electrolytic. I'll hook that up like that. I'm on electrolytic. I've got you zoomed in a little bit here, but maybe I can move this a little bit. Alright, let me back off just a hair here. Well, I have to back off a lot, don't I? Trying to get it all in the shot, but you know what I'm doing here. There's electrolytic. You can see that. You should be able to see that good enough. Electrolytic on discharge. We're starting at the bottom here. And I'm going to go to leakage. 6, 10, 15. Should be about 100. There it goes. Before it starts showing. 150. And this is good for 350. They're supposed to be. 200. 250. See, it should have already been opening. Even though if you sit here and hold it and wait a little bit, it'll eventually open as it reforms that capacitor. If it ain't open by now, you know, it's bad. Of course, these other ones like this, it's just need to get rid of them. I know there's some that'll argue that, but you need to get rid of them. It's just, capacitors are cheap, and there's no sense in trying to reform it and reuse it and then put it in your equipment and why it's working, man. You know, like this one over here, we was showing it was, that's okay. And then a day down the road, a week down the road, 10 days, especially if it's something, you know, real, your big nice audio amplifier or something like that. One of these things shorts and goes out and takes out an audio transformer or something that's, yeah, you'll be wishing you quit listening to those guys that tell you to reform them. But look, we're still there and it ain't open, so that's definitely a bad one. Let's just see what it reads on. It's discharged. Okay, let's go. Let's see, it's discharged. Let's go there. I don't know if you can see it in the camera, but that one is showing on off scale like 65 or something. So, and it's only reading, I mean, it could be that far off, but it's most likely reading high because of the parallel resistance. Okay, so let me do another one here before we end the video here. I know it's gotten kind of a long video. This is another one that came out of it, and I purposely saved these to show you the ones that actually came out of this unit. Okay, that one will go down to paper, and it don't matter you hook it up when you're doing this, but I'm going to put this on the full end, but it'll be the same either side. This don't matter where this is at because we're not checking the capacitance, we're checking for leakage. Power factors in electrolytics, so 3 volts leakage. You see that? That one's pretty bad. It's supposed to be maybe 200 volts. Put some more voltage on it. It just, and if you try to Now if you overvoltage it and come down, see how it's reformed a little bit. But you see that how quick it's still close. Look at that. This one's got some internal leakage. I mean, that one's probably arcing. If I hooked up my signal tracer and brought it around it and listened, I bet I could hear some arcing in there. So yeah, I don't want to run that all the way 200 volts. I start seeing some stinky stuff come out of it and smell up the shack here. So alright, go back to discharge. There you have it. And again, I'll say be careful with these. Don't probing your hands in there without paying attention to what you're doing. Have some plenty of light on the subject, and all that stuff will be half asleep and half a case of beer, nothing like that. You can really hurt yourself. I hope you've enjoyed this video. Hope it helped somebody out. Seeing what I've done here and seeing how I went through everything. If you have any questions or comments, just put them down below. Want to see anything different, I'd be glad to throw another little video up about something if somebody wants to see something or whatever. But that's it. Yeah, I mean, you can put in resistors too. Go over and check resistors, things like that, and whatever. But most people use these to check capacitors. Take these suckers and see if they're still good. But I just mostly throw these away. Where I will use something like this if something is, and something that's only 30 years old maybe or something, and it's been kept in a good environment. I'm like, well, I probably should chunk it, but let's just quickly test it or whatever. But I don't know how many of these I ran into this made like this. Every one of them's bad. I don't care what kind of one of these testers, a modern day tester. Some people you can't use a low voltage tester. You gotta use high voltage. You gotta use this. Some people says no, you gotta use gen rad. You gotta use whatever I've put it on. They're always bad. Cheap meter to expensive meter. Or not real bad. Maybe they're half bad. But this one here is pretty bad. And I don't know if this here, it was like that when I took it out, is where it's trying to leak internally something through there, or if this has got something that was got on it. Because, the story of this. But anyway, until the next video, this is Michael, KE4EST 73.